Okay, so so now this is the one which was there and was left. So instrumentation amplifiers are basically nothing but they try to amplify the difference of the voltages. So let me draw the diagram for this instrumentation amplifier first.
So have you started the recording?
Yes. So we have this as R2, then we have R1. Minus plus, then we have V2. So now I think most of you are comfortable with writing out the equations for for these things. So can you tell me what will be the value of VO1 here and VO2 this side? I'll give you 2 minutes to do that. Calculate the value of VO1 and VO2.
Sir, one doubt is there, sir.
Yes.
Sir, can we take these three resistors as common resistor R2, R2 and R1 as R equivalent? Can we do like that way?
No. You cannot look exactly what you are trying to say. I'm not getting it.
Sir, this R2, R1 and R2 are in series.
How
So we
can
can
you
do
say
like
they are in series?
so we can substitute R equivalent in place of these three resistors.
I no, you cannot do that because already there is a connection with the operational amplifier also, right?
Okay, sir. Okay, sir.
V1 into 1 plus R2 upon R1.
So for what you are saying, VO01,
Uh,
what value you are getting? V1
V1 into
into
1 plus R2 by R1.
Sir, I can say,
yes.
sir, VO1, which is equal to V1 minus V2 by R1 plus V1 by R2, and the whole multiply by R2.
Can you repeat V1 minus V2
V2 minus V2 by R1
by R1?
plus V1 by R2,
Okay.
and the whole thing is multiplied by R2.
Same,
Okay.
sir.
Okay.
Yes, sir.
So most of you are getting the same thing.
Yes, sir.
Yes, sir.
Yes, sir.
So VO2 is basically V2 plus R2 by R1 times V2 minus V1, and for here you have VO1 as V1 plus R2 by R1 times V1 minus V2 plus V1. So this is the expression that you are getting. So if you want to calculate VO1 minus VO2, so effectively what you are getting is basically this expression. So what exactly is this? Is basically when you are trying to take the voltage difference between VO1 and VO2. So that difference of the voltage is scaled by a factor of 1 plus 2 times R2 by R1, and that scaling is multiplied with the difference of the input voltage, which is V1 and V2. So what this instrumentation amplifier is basically used for? It's basically used for amplifying the difference in the voltage between V1 and V2. In some applications, what happens is we try to find out the difference of the voltages, like we find out difference of the voltages which is important to us. So that difference of the voltage is actually amplified by a scale of 1 plus 2 R2 by R1, and that scaling will give you the result which is the difference in the output voltage. So normally instrumentation amplifiers are used for amplifying the difference of the input voltages. So this is basically the application for, yes.
So can you explain how we derived the V naught one, like anyone, so we can
What's your roll number?
180, sir. Means I'm kind of confused. I'm not getting the same answer. That's why.
No, no, it's okay. I just wanted to ask the roll numbers. And for this person who wrote this expression, what was his roll number?
170, sir.
Okay. Okay, so the thing is, if you are
Sir,
not
sir,
getting
I write second one, sir. V note one. Second one is there that
second one, which one?
V note one, which is equal to that I wrote.
This one, V not one, right?
That 170.
What is your roll number?
My roll number is
170.
170.
Oh, okay. Who is this person who wrote this one?
146.
Okay. So the thing is, uh, if you are not able to get it,
Sir,
yeah.
sir, the only difference which is coming is like I'm getting V2 minus V1 in V01 expression
But
instead of
are
V1
you
minus V2.
subtracting V01 minus V02 or the other
No,
way
no,
around?
no, the V01 expression.
Oh,
Like
okay.
R2 into V1 minus V2, I'm getting R2 into V1 minus V2 minus V1.
So you are getting it for V01.
Yes, sir.
Oh, okay. But it should be V1 minus V2 actually, if you calculate for V01. So things are pretty simple here. So let me do it. I think since most of you have got in this quiz the answers, so that leaves me in a doubtful state whether you people have cheated or you people were really solving it by yourself. So because this thing is very simple, right? So here you have V1, this side you have V2, as it's a virtual short, right? So here this is zero current and here also you have zero current. So if we have these things, you can easily write nodal analysis at this node, which is this red point. So what is that? It is V1 1 over R1 plus 1 over R2 minus VO1 by R2 minus V2 by R1 equal to 0. So this is the first equation that you will write for this particular point. For this particular point, you will write it as V2 1 over R1 plus 1 over R2 minus, this is, let us say, VO2. So here we have minus VO2 over R2 and then minus V1 over R1 equal to 0. So this is the second equation that you will write at this node. And then you also know that V1, oh yeah, that V1, V2 is already taken care of. So now you can easily write the difference of the voltages in between the two, or you can separately write VO1 as a function of V1 and V2 and VO2 as a function of V1 and V2 from this. So once you evaluate it, you will get these answers. Okay. So roll number 180. Are you comfortable with this now?
Yes, sir. So this was the same thing, just that we have not considered that R2 upon R1 is greater, means very greater than 1, right?
No, no, no.
Because
That
we
is
did
not
this
required.
previously.
No, no, that is
We
not
did this
required.
type of the thing previously where the amplification of subtraction was
Yeah,
there.
yeah, yeah. That, see, the thing is, all these things which I was telling you earlier, that R2 is much, much greater than R1 and all these stuff, they were just given to you to provide you with an insight that, if these things happen, then you will get the amplification. But in general, if I am not doing that type of simplification, then you do not have to do all these stuff which is given over here, like the one which I was telling you, because this is something, different. It's beyond the expressions. We want to gain some insights from the expression. So in order to gain these insights, we normally do these type of visualizations to actually see whether the amplification is really happening or not, because these things simplify the expression to a bit, and then we can find out, okay, yeah, amplification is coming when we do these type of approximations. Okay. So
Yes,
these
sir.
are basically some approximations that we normally perform.
Okay.
Okay, so this is actually instrumentation amplifier. Now there is one more amplifier which I guess I don't know whether it's there in your course or not. It's called as transimpedance amplifier. So that amplifier is nothing but it is like this. So you have something like this here, and then we have a current source I in like this, and then we have a resistor R. So we have V out this side. So can anyone tell me what will be the answer for this particular circuit?
V out equals to I in R.
No, it's not right. Any other answers?
Hello?
Yes,
Minus I in into R.
yes. So actually, V out is nothing but it's minus I in times R. So this is basically called as a transimpedance amplifier. And why it is called as transimpedance amplifier? Because it is actually converting the current into voltage. So you are actually feeding input as a current, but you are getting output as a voltage. So if you see, it's basically if I calculate Vi in by I in, it is called as impedance. Okay, it is called as impedance. When we will look into AC analysis, there you will find these terms more, but for now you can say that it's called as impedance, which is also called as Z in. We will understand all these terms when we will do AC analysis, but if you are doing it at a single end, that is at the input end, if you are calculating the V in and calculating the I in, then this is called as impedance. But here in this case, what is happening? You are actually inputting the current I in and measuring the voltage V out at the output port, a second output port. It's not here. So that's why we call it as trans impedance. Trans is
Here minus.
coming trans is coming because you are actually taking output here, but you are applying input here. In this case, what you are doing, you are actually applying input here and measuring the output also here. So that's why we call it as impedance. Trans impedance means you are calculating voltage at the second port, but inputting in the first port. That's why this trans comes into play. Okay.
Sir,
So
here minus
sorry, can you come
minus
again?
मतलब आंसर में V आउटपुट इज इक्वल टू
Yes.
माइनस आई इन टू आर, ये माइनस टर्मिनल की वजह से ही आया है.
No, no, it's not because of minus terminal. Can anyone tell me why this is coming?
सर वो तो नोडल एनालिसिस किया तो वहां पे माइनस के बाजू में 0 वोल्टेज होगा क्योंकि प्लस में अर्थ वो अर्थिंग की है. तो सर नोडल एनालिसिस करेंगे तो 0 माइनस V अपॉन R इक्वल्स टू I हो जाएगा.
नहीं वो ठीक है, but by simple analysis also you can see that this current is going like this, right? If it is going like this and it's not going inside this, so the drop in the potential is created in this way. So if the drop in the potential is created in this way, then with respect to ground, this voltage V out is minus or not?
यस, नाउ आई गॉट
That's
इट.
why
Yes,
it's
sir.
minus. Okay.
सर इन्वर्टिंग टर्मिनल है इसलिए ही
No,
है
no,
और
it's
है ना.
not because of inverting terminal. It's because of the direction of the current which is flowing. So direction of the current is flowing like this. So it's creating a plus to minus drop. So with respect to ground, your V out is negative. That's why this minus is coming. Okay, so there are some terms which were left earlier. I'll try to finish them fast because they are there in your course. So I just wanted to make sure that these things are covered. So let us say you have unit impulse. So this is some special signals which I will try to tell you today. So these special signals are noted down uh, now. So you just see what they are. So unit impulse is basically defined as this special symbol which is called as delta, and this is nothing but its zero value at time t not equal to 0, and it has a value of undefined. It's undefined at time t equal to 0. So this is basically the definition of the unit impulse. That is, its value is 0 on all the other locations, but its value is undefined at time t equal to 0. But when you take integration of this particular, special function which is delta t dt, the value comes out to be 1. So this is the general definition for this impulse function. So there should be no confusion in terms of understanding it, because this is the definition that we have to take into consideration. So it's like Newton laws. So once this is defined, then we can actually do several things which we will be dealing when we will be doing RC analysis and transient analysis later. But this is very important, one of the important functions which we call as unit impulse, and we actually draw it like this. You have a time scale axis t on the horizontal, and on the vertical side what you do is you represent it by a arrow like this, and the value of this is given in brackets as 1. So what it means is, like, its value is 1. Its value is 1 at time t equal to 0, and for other time intervals its value is not its value is 0, and at time t equal to 0 its value is 1, and this value is written in brackets. It means it's an area actually, and it's not a value, because the magnitude of this impulse is undefined. As you can see over here, it is not defined at time t equal to 0, but the area is 1. So that area is 1 is actually written in terms of brackets. So this is unit impulse. So if you are thinking that how we are getting this, you can easily understand it by visualizing a pulse. So let us say you have a square pulse having a duration of a and minus a at time t equal to 0, and the magnitude of this pulse, this amplitude, is 1 by a. So you can say not a, you can take a by 2 and a by 2. Okay, so now what will be the area of this square pulse that you have here? 1, right?
One.
One.
The area of this will be 1. So if I make a tending towards 0, what can you say about the width of this pulse?
0.
So as a will move towards 0, means this line will go this side, this will go this side, right? So it will be, the width of this pulse will decrease. But what can you say about the amplitude of this pulse?
Tending to infinity.
Tending to infinity.
Right. So that means you are actually moving from a pulse to some intermediate signal like this, and once you move a further down, then you will have a situation like this. So which is this one. So basically you can visualize and understand that you are getting this type of signal from a pulse whose width can be reduced to 0. So basically, this is the concept which is actually required in your signal systems courses, which will be coming later down in your semesters. I think in second semester you will understand what I'm trying to say here. But this is a very fundamental concept, and it might be used in your coming lectures, like in fourth or fifth unit. So that's why I'm trying to cover it here. So this is unit impulse. Okay. Then we have unit step. So in unit step, what unit step is defined is as, it is defined as ut. It is defined by a symbol ut, and what is this mathematically? It is basically 1 when t is greater than 0, and it is 0 when t is less than 0. So this is the definition of the unit step. So if you want to see pictorially, it is represented like this. So you
So,
have
sir, it is a mathematical function.
Yes, it's a function, but we are actually denoting it by some special names. So it's definition, by definition it is called as unit step. So here, just a second. Here it is ut, and the magnitude of this value is 1. And for the rest of the values below 0, time t equal to 0, its value will be 0. So this is the definition for unit step. Yes. Yes, you have any questions?
Sir, what is the value of ut at t equal to 0?
See, at the t is equal to 0, normally in signal systems course, or in in the coming courses that you will be studying, is irrelevant to us, because normally we do not work on these values at the discontinuity. We are actually a bit ahead of it, and we are interested at these points. So
Okay,
things are very rare that you will be asked to calculate the values at time t equal to 0. But for this, if you, in case you are interested, normally they take it as 0.5. But it's not wise to take that 0.5, and the situations are actually rare to rarely it happens that you need to calculate at time t equal to 0. So so that is out of question here. So this is basically unit step. And then if you want to actually move a unit step by a timed interval t0, let us say if I want to move this unit step ahead in time, then we do it by this operation, which is basically represented as u of t minus t0. So if you write u of t minus t0, that means your unit step is actually moving ahead in time, and it will start at time t equal to t0 like this. So earlier your unit step started out from here, but now when time you are shifting it by time t0, so it starts from t0 like this. And why it is happening? Because you can do it like this. So let us say you have ut minus 4. If you want to calculate this, so if you want to calculate this, then what is the value of x of 4? The value of x of 4 will be the same value which is at u
u0.
of 0, right? So you can now visualize that whatever value that you had at time t equal to 0 will be, that same value will be there at time t equal to 4. So this is basically, that's why it is shifted towards right side. I hope you have no questions in this, like it's very easy, right? So,
Yes,
yes,
sir.
sir.
Yes, sir.
and in case uh, things are ut plus t0, then what will happen in that case?
Backward.
It will move back.
सर पीछे
Minus
चला
t.
जाएगा
So it will start from here.
माइनस टी नॉट पे
Okay.
हाँ
So if it is t plus t0, then this particular signal will move from backward side. Okay, fine. So this is basically unit step, and then we have other functions also, which is let us say we have this unit pulse. Unit pulse. The unit pulse signal is denoted by pi t, and it's basically 1, 0, when modulus is less than half and modulus t is greater than half. So this is basically unit pulse. And unit pulse, if you plot this mathematical expression, so it will look like this. So its value is minus 0.5, 0.5, and this value is 1. So these things will come when you will be doing transient analysis later down. So all these expressions will be used at that time. So some of them, not all, but some of them will be used. So it's your exercise to do that. You have to do it yourself. That this unit pulse can be written as ut plus half minus ut minus half. So this you have to do yourself. Like you have to prove that you can get this particular signal which is given over here, which is pi t, which is actually nothing but it's a scaled version of ut plus, not scaled, it's a time shifted version of the unit step by half, and you subtract that from the time shifted version t minus half. So if you actually subtract these two unit steps, you will get this. So can you do this?
Sir, can we use just graphs to prove it?
Yes, yes.
Or
Yeah. Like for yeah, I was asking that same thing only. So here you have ut plus half, right? So ut plus half is starting from here. So at t minus zero point 0.5 it will start. And then you have ut minus half. So that ut minus half is nothing but it starts from here, right? So when you subtract the two, what will happen? This will go away, right? It will not be there.
Yes, sir.
So
yes,
you're
sir.
left with this, okay? So this is basically the pulse pi t. So you can represent these pulse in functions like ut and ut minus half. So these are actually called as basic building blocks. So unit step and delta functions are called as basic building blocks because we can actually use these these functions to build up these complex functions which are given. So another function which we have is unit ramp. So unit ramp is nothing but it's defined by r of t and then its value is t for t greater than or equal to 0 and its value is 0 for t less than 0. So this is nothing but it's basically defined like this. It's a line. Sorry, it will not be here.
Yes, sir. Only
So
for
so
सर
it's
वहां पे आपने क्या लिखा है यूनिट ये क्या है
ramp. So it's a unit
ramp.
ramp.
ओके ओके
So it's a unit ramp function. So its value is given like this, and it has a slope of 1. Okay. So this is a unit ramp, and it's defined by r of t. And you can use several you can use these also to build up some complex signals, which I will discuss now. So there is another signal which is unit triangle. So this unit triangle is defined like this, and it's mathematically defined as t plus 1 for t greater than minus 1 less than 0, and then we have t greater than or equal to 0 to less than 1, and otherwise it is 0, and then here you have minus t plus 1. So this unit triangle is, if you plot, you will get this. It's 1 minus 1, this is 1. So this is basically the triangle, unit triangle. So this unit triangle can be represented in terms of ramp functions like this. So you can see a triangle can be represented in terms of ramp functions like this. So can anyone tell me how I have written this? Like, anyone?
Sir, may I?
Yes.
Sir, first you have shifted ramp to the left side. That is by doing RT plus 1.
Okay.
Then, sir, you have done RT minus 1 with negative sign to inverse the ramp.
So RT minus 1 is not there, right? Only RT is there, right?
Yes, sir.
So what is this doing? So here you have just a second. So here you have
Sir, it will shift downwards.
yeah, it will shift downward. So see, the thing is r of t plus 1, will you all agree that it will be like this? Okay.
Yes, sir.
Yes, sir.
Yes, sir.
So that means you already have this portion covered up by this part. Okay. Then what is happening? This is continuously increasing, right? So we want to decrease it. So if I subtract a ramp which is RT, which is minus RT, like this is minus RT, right?
Yes, sir.
So if I subtract this minus RT, then what will happen? So this particular thing will actually cancels out the slope of this one, right? So once you subtract by a single RT, it will cancel out the rising slope. It will cancel out this rising slope. And once it cancels out that rising slope, it will become, let us say,
Flat.
this, right? And then again
Yes.
you are subtracting by one more RT, which is going down, right? So if you subtract by that, then what will happen? It will go down or not? So it will go like
Yes.
this. Okay, and now because you have this downward slope and you want to make it zero, because you can see here you have zero, right? So you can actually,
plus RT.
so that plus RT plus 1 is this one, right? So at time
Yeah.
t equal to 1, ramp is like this. So what will happen? This slope which is over here will actually cancels with this slope. So
Sir, it's RT minus 1, not plus.
yeah, RT minus 1.
Yeah,
But
minus.
yeah, yeah, I hope you understand this. This is quite
Yes,
trivial,
sir.
right? So uh, this thing actually cancels out with this one. So once you do that, what answer you will get? You will get this.
तो सर ये जो अभी आपने ये जो 3-4 टॉपिक बताए इसमें ये टाइप के क्वेश्चन आते
Yes,
हैं
it will come. It will come in the exams.
तो ऐसे
Sir,
नॉर्मल
how
बुक्स
it
में
will
मिल
help in
जाएंगे?
complex circuits?
Sorry?
Sir, you told that these all graphs will help in solving complex circuits then?
No, this graphs will be used in transient analysis. Like we will be, using these signals as input to our circuits. Like you will have R, C circuits, and then what we will do is we will pass a triangle function like this into the input of this and see what results we will get. So maybe we will be using all these situations. So we have to
Sir,
represent this in terms of
sir, the exam will be pure objective or there will be some subjective question also?
it will be objective. Subjective may or may not be there, but chances are high that you will get objective questions with negative
So,
So it
markings.
will be like quiz type?
Yes, it will be quiz with negative markings.
Okay.
Any other
so
question?
this type of questions means the last topic that we learned is completely about inputs, right? So we'll get to know about inputs and the different question from unit ramps or unit triangle or whatever it is given according to that.
Can you come again? I didn't get you.
I'm asking that the special signals topic that we learned right now is only for input purposes, right? Like we'll come to know about the inputs in the question. Like, is it given in that form or there is any other form in which the question would be asked?
It will be asked like, represent this signal in terms of unit ramp. So there will be some expression given to you. So you have to evaluate that and you will get the answer, right? Something like this. So it might be the case we will ask you some variations of these type of things. Okay. So you will
Sir, can
have
you provide
multiple
some
options.
example of this?